In my previous video, I demonstrated designing a finger jointed box with fingers that automatically resize themselves based on the dimension of the box and the number of fingers desired. In this video, I'm going to demonstrate designing a box with finger joints where the finger joints are a consistent width across all dimensions of the box. So the first thing that I want to do here is create some parameters. So I will set the length of the box to 150 millimeters, the width of the box to 75 millimeters, and the height of the box to 30 millimeters. I will also define the thickness parameter, and I'm going to assume that I'm designing for 1/8 inch thick material. And since I'm using metric, I will use 3.175 as the value here. Now I also need to define a parameter here for the width of my fingers, and I typically use the thickness times 3. I need a parameter to define the spacing of my fingers, and in this case I usually want it to be the finger width times 2. I also need to define some parameters here that tell me how many fingers I need across any given edge. So I need to use, and these need to be unitless numbers here, but I'm going to need to use Fusion360's rounding functions, in this particular case the floor and the ceiling function, and I'm not going to go through all of the math of why I'm using these functions here, but just to show you the formula. So I will take the distance that I want to cover. On this edge it's the length. I want to subtract 2 times the thickness, since there will be a wall on both sides. I will divide that by the finger width, so that tells me how many fingers I will have across the entire face. And then I need to divide that by 2 because I will only have half of the fingers on any given face. And then I need to duplicate that function for the width. Again, no units. And do the width. Remove 2 times the thickness. And the same thing for the height. Now on the height, because I'm only going to have a bottom on this box and I'm not going to have a top, I only need to subtract the equivalent of 1 panel. So I'm only going to do thickness here instead of thickness times 2. Now this formula that I use here with the floor and the ceiling, I've tested numerous iterations of this, and with varying results where the number of fingers will be 1 too high or 1 too low, or it will calculate the right number of fingers for certain measurements but not for others. So the formula that's here on the screen is what I've worked out to be consistent across the widest use cases. The one exception to this is that there's a minimum size to the box, or if you go below that size, the number of fingers will essentially break because the calculations don't work out. So as long as you don't need to make a box that's too small here, you'll be okay. If you do need to make a box that's smaller, then you're going to need to play around with the finger width and finger spacing to get things to work out correctly. But with those parameters defined, I will hit OK to close that out, and I can start my model. Now I'm going to start by creating a sketch on the XY plane, and I'm going to draw a rectangle from the origin and do the width, and try that again. Draw a rectangle with the width and the length, And then I'm going to extrude that out to give me my bottom panel. I will rename the body, and then I will rename the sketch. Now, if you saw my previous video, most of what I did up to this point was the same, except for the formulas were slightly different. And this is where they come in. So now I'm going to need to draw the sketch on this front edge where I can cut the notches in this bottom panel. So I create a new sketch. I'll select this front face of that edge. And I need to draw a rectangle constrained to the upper and lower faces of that panel. But I need to be able to have this first finger move depending on the length of this face and depending on the thickness of my material and if I play around with the finger width or the finger spacing. But I can't place this box in the center of this face, which would seem to be the obvious solution, because if I do that, I'll end up with certain sizes of this box where I end up with one finger too few on one side and things don't work out correctly. So to fix that, I'm going to find the center point here. So I press L to draw a line. I find the center point on this face. You can see the triangle. And I will drag it down to the bottom. Now I've got a line in the center of this panel. Now I want this to be a construction line, so I'll click on it to highlight it and press X to make it into a construction line. And I need to draw another line across this face. And I want to make sure that it's at a right angle to that center line. And again, click on it and highlight it and then press X to make it a construction line. Now this line is going to change sizing change length based on the dimensions of this edge. So I'm going to press D, highlight the line, and right now it doesn't matter what this number is. I'm going to press enter so I've got a dimension there. I always want to make sure that this line is centered around the center of this edge. So I'm going to go over to the sketch palette. I'm going to click on the midpoint constraint, and I'm going to click on this center line, and then I'm going to click on this other line. Now, no matter what I do, if this line gets longer, if I actually give this line a specific distance and make it 75, it's always going to be centered around the center of this panel. And then I'm going to, again, use a constraint. So I'll pick the coincident constraint here. And then I will click on the leftmost point on this center line. And then I will click on the left edge of the rectangle that I drew. And we can see that now this rectangle is constrained. So this left edge of this rectangle will always be coincident with this point on our reference line here. Now I also need to add a dimension constraint to the rectangle. So I will press D, click on that top line. I will click on this and then enter the finger width parameter so that my notch that I'm going to be cutting here is in the right place. Now I can press E on the keyboard, and then I will do a negative thickness and cut a notch in this panel that's equivalent to the thickness material that I have. Now notice the notch is not at this point where I want it. What I want to do is now do a rectangular pattern. I will copy this feature. I will select the direction. I'm going to use the bottom edge here. This time I want to use spacing. In my previous video, I used the distance type of extent. Now I want to use spacing. So the spacing is going to be finger SP, which is the spacing parameter that I used. And then the quantity is going to be L fingers. Again, the notches are not positioned correctly, but if we go back into the change parameters, we can see our dimension here, the 75 millimeters, and we have our count for how many notches we're cutting in the panel. So the dimension is going to be L fingers times 2 minus 1. And then I need to multiply that by my finger width. And it would help if I put the right number of parentheses in there. So now that line is going to automatically change based on the number of fingers that will fit along this edge. You can see the line has gotten longer, and the rectangle moved with that line, and the number of notches is consistent along that length. They're equidistant from both edges, and we're good. We can go up here and change the parameter if we want. I can change this significantly to make it longer, and the number of fingers increases, but they're still placed so that there's an equidistant face, or equal length face from each edge. So I'll go back, I'll change this back to 150 millimeters. And then I can turn off the sketch. I don't need it anymore, but I will rename it. And then I will draw another sketch on this left face of this panel. Again, I'll press X right now to turn on the construction line mode. Press L because I want to draw a line, and I will find the midpoint of the face. Now I have the reference line in the middle. I will draw another line that's at a right angle to this center line. I will add the midpoint constraint to these two lines. I'll add a dimension to my reference line here. Again, the length, well, we can type the formula in here. So we can do W fingers times 2 minus 1 times finger width. Then we can create a rectangle, constrain to the two edges, and I forgot to turn off construction lines, so let me turn off the construction lines and draw the rectangle again. I will then press D, add a dimension constraint to make that rectangle the width of my fingers, and then I will use the coincident constraint, click on the point here, and then click on the edge of my rectangle. I'll stop the sketch, and then I can press E to, if I can type correctly, cut the finger in that face. Now I can use the rectangular pattern, select the feature that I just created, select the direction that I want to go. Again, the quantity here is going to be W fingers, but the arrow is pointing in the wrong direction, so I want to do negative finger spacing here. And that gives me the notches that I need in that face. Now I'll rename that sketch. And now we can draw the walls that we need. So I'm going to draw another sketch, this time on the XZ plane. I will use a 3-point rectangle, click on the origin, click on the lower right corner of the bottom panel, drag it up, and then type height. And then I can extrude the panel. The arrow is going in the right direction, so I'll use a positive thickness here. Make sure that the operation is set to new body. Click OK. I'll rename this sketch. And I'll press A to apply an appearance here. again, if you've seen my configuration video, you'll see how I configured my appearances to do this. There's interference now between these two panels, so I want to select the combine option, select the front panel as my target and the bottom panel as my tool. And now I've got my fingers and notches cut in that front panel. Now I can create another sketch, this time on the left face of the front panel. And I'm going to go into construction line mode, find the center point here, draw my line, draw another line that's at a right angle to the center, and then I will add the midpoint constraint so that these two lines are centered around each other. And I'll turn off construction line mode and draw a rectangle, constrain to both edges, and then add my coincident constraint, click on the point on my reference line, click on the lower line on my rectangle, add a dimension constraint to my reference line. This is going to be H fingers times 2 minus 1 times finger width. And then I need to add a dimension constraint here. This is going to be finger width. Now I can extrude the notch in this panel. I want to cut into it, so I'll do negative thickness. And I've got my notch in that panel. Okay. So now I need to use a rectangular pattern. I will select my feature. I'll select the direction, and I will go up. I want to make sure that I'm doing H fingers since it's the height, and I want the arrow to go the other direction, so I'm going to do a negative finger spacing and click on OK. Now we can't see any other fingers because we only need one finger here. If I change the height, now we should see the second finger. And if I make the box even bigger, we should see the number of fingers change and our model updates. But notice that all of the fingers and notches are the same width. So now I'll go back to 30, and I will rename this panel and rename this sketch. Now I will copy this panel. I'll press E, highlight the back face of this panel. Since that's a profile I want to copy, I will change the start to from object, select the back face of my bottom panel, and I want to do a negative thickness for my extrusion distance because the arrow was pointing the wrong direction. And again, the operation I want to be new body, and click OK. Now if we turn off this body, we see that there are no fingers, or no notches or fingers in the bottom panel. But if we turn off the bottom panel, we can see that we've got all of the fingers and notches in the back. So now I will take the combine tool, select the bottom panel as my target and the back panel as my tool, make sure operation is set to cut, and keep tools as enabled, click OK. And if I press A on the appearances and go to faces and drag and drop the MDF board appearance to the back panel, you can see the fingers cut correctly. And I will hit close. I will rename this back panel. Now I only need one more sketch here. And by the way, the reason I use sketches to draw these instead of going up and creating boxes is that if I want to use this design in another project, having the sketches available gives me a place to put other constraints or other features. If I want to cut holes in the box, or if I want to drive the sizing of the box based on other features, having those sketches available, even if they're simple rectangles right now, having those sketches available gives me a lot of flexibility in the future. So that's why I generally use sketches even for something as simple as extruding a box. So I'm going to create another sketch, this time on the YZ plane, and make sure that you're not accidentally drawing on a face for one of these other panels. So like I just clicked on it and went to the wrong place. So draw a sketch on the YZ plane. Do a 3-point rectangle from the lower back corner to the lower front corner, and then up to the upper front corner. And we've got a rectangle. We can press E on the keyboard and then highlight that profile, and then enter thickness as the distance that we want to extrude. We want our operation again to be a new body, and then press OK. We've got our left panel with no fingers or notches in it. So we will use the combine tool now with the left panel as the target and the back, bottom, and front panels as the tools. And we've got all of our fingers and notches visible. Operation is set to cut and keep tools is enabled. Click on OK. And now we've got our left panel created. So I will rename that and rename the sketch. And I will press A to apply an appearance here, again with my MDF board appearance. And our left panel is complete. Now I simply press E to bring up the extrude dialog, select the profile for my left wall, change the start point to from object, and then select the right face of the bottom panel, and then enter negative thickness, since I want the arrow to go the other way. Change the operation to new body, and click on OK. And again, we can see there are no notches on these panels, but we've got the fingers on this right-hand panel. So we use the combine tool again, select the front panel as the target, and the right panel as the tool, operation cut and keep tools. Same thing for the bottom, combine with the bottom as the target and the right panel as the tool. And then once more with the back and the right panel as the tool. Now all of our notches are cut and the fingers are cut as well. I'll press A one more time to bring up the appearance dialog, select faces, and then drag and drop the MDF board material to those faces. Close that out. Rename our right panel, and our box is complete. So now, in the previous video where the fingers would change sizes, again, if I go up here and change the size of my box, my fingers and notches are going to stay the same width, but the number of fingers and notches is going to change based on the dimensions of the box. And now here's an interesting problem. When I drew the sketch for this left panel, and this happens periodically, the rectangle for that panel did not, for some reason, did not connect to this reference point. It clearly knew that's where I wanted to go because it added the projection point for this reference point, but for some reason they did not align correctly. So I can fix that very easily. I just went in here to right click on the left panel sketch. I'm going to go to my coincident constraint. I'm going to select this point, and I'm going to select this top line. That automatically constrains the line to that point, and stop the sketch, and everything's fixed. Now, if I was paying attention, which I probably wasn't, I would have seen that this line was still blue. It wasn't black, which meant that the constraint did not take effect for some reason. But that's just something to watch out for. But again, having these sketches available makes it easy to fix things like that. So that's fixed. Our box is the right size. The fingers adjust appropriately. And I think that looks nicer than the other box where the fingers are different sizes across all three edges. But again, this box will have a problem where the fingers, the dimensions of the box below a certain point, the fingers will not calculate correctly. Or you may end up with no fingers at all on a specific face, which means you can't really put it together. But for most boxes, this is perfectly fine, and this is reusable for the future. So I will just save this as an open top finger jointed box, and now I can use this in the future. So I hope this video was useful. Please leave feedback or criticism in the comments below, and I look forward to seeing you in the next video.